Hello and welcome back to Brain Academy. This is episode 3, and today we're going to be covering how to set up character movement in Unity. So without further ado, let's get started. So first off, I'm back here in the scene that you would have set up in episode 2. You can see it's the same. You might have something a little bit different. I've just added a directional light so we get a little bit better light on our character. So we're going to go into 3D assets and characters. And then we're going to go to this character over here. Just disregard the pink shading. That has to do with some shader stuff that we'll cover in a later episode. So once you drag him out here, you're going to see it doesn't look quite right. And that's because the materials on him haven't been set up yet. So as you can see here, we just have some default materials. So we're going to go into the materials folder. And then we're going to go into characters. And we're going to grab these 3 pink ones here. Once again, you'll learn more about this once we cover the shaders. So just drag them in here. You gotta get them in the right order so they apply properly. So here we go. Alright, and there we go. We've got our textures on our character now. And now we can begin looking into exactly how this works. So, as you saw right there, I was rotating the base, which isn't actually something you can change. That is the actual model. And then the one above it, the armature, is the skeleton. So the basics of how the animation works is you can rotate parts of the skeleton and the model will follow after it. There's currently no animations on here, so we're going to go through how to set that up. So we're going to go into animations, and we're going to open up this text document here. And this comes from Calden, who has done all of our modeling and animation on this project. So he's left this as a handy little guide to how you can set up the frames. So, as you can see here, each of these is a reference to a set of frames that make up the animation. So the T-pose, for example, is the first 5 frames of the animation. So in order to get those off the actual model, first we're going to go in and we're going to create an animation controller here. It will allow us to control which animations play when. So we're just going to name it Player Controller. Alright, and if we click on this, it's going to open up the animator. This is a tool for setting up animation trees in Unity. A bunch of features here. At the top, you can set different triggers for animations. So like when something's true or false or when something happens in code. And then we just right click and we can create an empty animation here. And from entry, it will immediately go into this animation. So entry is the start point of the tree. So we want it to go into idle right away. However, we don't have any motion here, because we don't have any animations to put in here. A few other things here, we can adjust the speed the animation plays at. So you can just drag this and slide it up and down. We can make it start on or off at a different frame. Or we can mirror it so it plays backwards. So we're going to have to go and get some actual animations to put into this tree. Go back to the character model in 3D Assets Characters. What we're going to do here is on the sidebar here, you can see there is the rig option here. We're going to want it to be generic because that's how our animations are set up. And if we go into animations and we click on import animation, then we will have a whole bunch of options once we apply it. Alright, so in here we can see this little view down here, which will give us a preview of what the animations are going to look like on our model. So you can see them going through all the different frames that we saw in that text document. Now we've got to bring that text document back, and that's going to tell us which frames to put where in the animations. So I'm going to put this on my other monitor so I can reference it. First, we want to get the T-pose. We don't actually use this animation, but it's a good thing to have in case you ever want to do ragdolls or anything like that. So just put in the first box, the first number, second box, the second number, so 0 and 5 here. And then those will be the frames in which this animation plays. So it's a little jittery there, but doesn't really matter. We're not going to be using those frames anywhere. So we're going to move right on to the idle. So same thing, put in your boxes here, and then name the animation. And we want this one to loop, because when we want the bot to be standing still, we want it to keep playing through this until you do something else. All right, and then we're going to make walk here. This one is a little bit of a longer animation, and we want this one to also loop, because as long as you're moving around, we want you to be playing through the walk animation. And then every time you hit apply, it's going to save any changes you make in here. If you mess anything up, you can hit revert, and it will undo anything you've changed. So I'm just going to go through and I'm going to make the rest of the animations here. Run, and then our jump animations. Now the jump animations are separated into a few different parts, and we'll see why when we set up the animation tree. But for now, just name them Start, Rise, and Fall. And we don't want this one to loop because this is the start of the jump, so we only want it to play it once per jump. Yep. And we don't want to loop this one either, because we just want it to play as you're going up into the jump. However, Jump Fall, we are going to want to loop, and this is going to play as long as it needs to until you hit the ground. So if you fall off of a high height, this is going to keep playing until you impact with the ground. So it needs to loop just in case your fall is longer than your actual the time of the animation. Okay, so now that we have all of our animations exported, you can hit this little arrow and you can see them all right here. And we're going to go back into the animator, and you can actually just grab these and drag them onto this board here. So go down, grab jump, throw it on there, and it's there. It's already got the motion in it. So I'm going to drag them all on here. Because idle, we've already made one, we just drag the motion up to the little motion box. And there you go, that is now applied properly. So right now all the tree will do is go from entry right into idle and just keep playing idle. So I'm just going to organize these how we're going to end up setting up the tree. And then we can begin. Okay, so the first thing we're going to do is set up the basic walk-run cycle here. What I just did is create two transitions, and you can do that by right-clicking on the box, and it will give you this little make transition thing. And here what I've done is connected both walk and idle to any state. So any state is a special node on this tree, and it means that no matter what you're doing, there will always be the option to transition from that animation to anything connected to any state. So we always want to be able to go into idle, and we always want to be able to walk, no matter what we're doing. However, as it is right now, there's nothing telling the animation tree what to play when. So we're going to go up here, we're going to click on this little plus, and we're going to make some triggers. So the way these work is they can be activated in code, and essentially what it does is you put it on one of the transitions, and when it's called in code, it will tell the animation tree to go through that transmission and then play the animation. I'm going to make this kind of transition loop between walk, run, and idle, so that if you're ever running, then you can go right back to idle, and if you're ever walking, you can go right back to idle. And then I'm going to click on these transitions between any state and run and any state and walk, and I'm going to add a condition to them. So the way the condition works is this is what can be called to activate this transition, and as soon as it's called in code, I'm going to go from any state and we're going to go right into idle. And then I'm going to do the same thing on the walk run, or the walk idle and the idle run. And these will make it so that if you're in run, you can stop running and it will go into idle. And if you're in idle, you can start running and it will immediately go into run. And the same thing for walk. And what we want to do is we also want to turn off has exit time. Basically what this means is that if you're in the middle of an animation and it has an exit time, it's going to wait until that animation is finished and then go through the transition. So what this means is if you're running and you stop, it's going to continue that run animation and then go into the idle, and then you're going to run on the spot for a second. So we're going to want to turn that off and do the same thing for walk, so you immediately transition from walk or run in idle. All right, I'm going to go back to the scene, and here in the animator component off to the side, you can see that we don't currently have one, so we're going to drag the player controller in there. And now this animation tree is on this model. So if we hit play, it's going to play the idle animation because that's all we've told it to do at the moment. And you may have noticed there, the idle animation was a little bit jittery. Let me just play it again. And you can see there's a little bit of a stop and then a go. And that's because the animation isn't perfectly aligned. So what we're going to do is we're going to speed it up just a little bit, and that will become a lot less noticeable. And there we go. It's a smoother animation, and he bounces a little bit faster. And here we're going to also want to organize our tree a little bit. Just make sure you keep everything in kind of a cohesive grouping, so things that have transitions to each other, try and keep them close together so that you don't have transitions stretching across the whole screen. And then we're going to want to also create a transition from walk to run, and this will allow you to be walking and then press a button, you'll go immediately into the run, and we're going to set the condition on that to be run. And then we're going to start working on making the jump tree. So this part of the tree is probably the most complex, because the jump has three sort of components to them. There's the initial jump, and then there's the animation you'll make when you're continuing your momentum upwards, and then once you reach the peak of that momentum, you'll switch to an animation where you're falling. So right here we're going to make a transition from the rise to the fall. So we're going to make a trigger. We're going to make two triggers. We're going to make one jump and one fall. And from any state, we're going to make the jump trigger go on this transition here. So you'll be able to jump from whatever state you're in. And then from the rise to the fall states, we're going to want to make a transition and put the condition on it for fall. So this will mean you'll jump, you'll rise up, and then once you're at the top, you'll fall back down and then go into idle. And you're going to want to turn off the exit time on that one. Now the tree is pretty much set up. We're good to go. All we have to do now is hook all of these triggers up in code. So currently you can't move or jump, so those animations won't play. If you look on the player controller here, you can see we have our animator, but we don't have any scripts to back it up. So we're going to go back up to the assets, the root folder, and we're going to make a folder called scripts. And then we're going to go in here and we're going to make a C# script. Create, and then C# script. And then we'll name this player controller. And open it up. And this will open up Visual Studio, which is a coding software that is used in conjunction with Unity. And in the sidebar here, you can see a little preview of what we're going to see. And here's the actual Visual Studio interface. So here there's a whole bunch of code jargon and whatnot. I'm not going to attempt to explain this. So I'm going to pass this off to our coder, Agusha, and she's going to walk you through how to make the player controller script.
So to start off, as Adam mentioned, I'm Agusha, and we are going to go through what code we need to make the player controller, allow them to move, play the animations, and jump. To start off, we're going to need to write 4 variables. All of these are serializable and private, meaning you can edit them in the inspector, but other scripts can't touch them. Range allows you to set between the 2 numbers, so you can't go over when you're in the inspector, adds a slider, and then the first value we're putting down is base speed, so how fast you want the player to move without sprinting. The next is the base sprint mod, which allows you to determines when you press shift, how much more you'll run. The next value is the jump speed, which determines how far you jump, how high up you jump. Using the defaults is great. These ones we've tested with, but you can play around with it in the inspector after. And the next one is gravity, determining how quickly the player will be affected falling. So we decided to go with 9.8, which is the standard gravity on Earth. Now we'll do the private components. These are references from other scripts. So here we have the character controller. This is a script that allows you to modify how the player moves. The next one we're using is animator, which allows you to start and set the triggers for the animations. And now we want to make sure that the game object has that reference. So we're going to do a required component of type animator and then also type of character controller. This way we make sure that when we click this one script, it'll appear on that game object with the other scripts that are needed with it. Now we're going to add the vector 3, which is the movement's direction. A vector 3 is a value that has 3 components to it, x, y, z, and has direction and magnitude. So it's basically a line in 3-dimensional space. So now we're adding an enum, which is basically, you can have a bunch of different states for a variable, and the ones that we type in. So we're adding idle, run, walk, jump, fall. These are all for the animation states that we're going to have, as Adam already implemented with the triggers. And we're going to add the current state variable, which allows it to be that property. Now in awake, this runs as soon as the game object is spawned into the level, so it'll run at the very beginning. We're gonna get those components off the current game object, the ones that we added at the top, so the character controller and the animator. In update runs every single frame. We're going to calculate the movement, which we'll fill in later. We're gonna get the character controller and make it move to the whatever the movement direction is, the final position that we want the character to be in, with time.delta time. So time.delta time refers to the time between the last update, so that you keep it frame rate dependent rather than if you are running this game on a super fast computer, you're just going to be zooming past. Now, set rotation. This is going to determine the way the player's facing. Now we're going to create the set rotation, which determines which way the player is going to be facing when they're moving. So if x is greater than 0, it means that it's that they're going to be going towards the right, so we want them to face the right direction. And then if it's less than 0, they would be going to the left, and they would need a negative 90 rotation. And this rotation's done on the y-axis. Now, next is to calculate the movement. So, first we're going to get the x input, which is going to use the input.getAxis. And input.getAxis returns a value from -1 to +1. We're going to get it on the horizontal, which is the Unity default arrow keys and AD buttons. There are other forms of getting input, like get button down, get button, etc. You'll see them later. So we're going to see if the input is not equal to 0. That means that there is some direction they're going to, and we're going to make that movement.x equal to that input times the base speed, so that they move the movement speed you tell it. Now, if the player is grounded, it means that they are on the ground and they can sprint. So then we add to that movement direction. So now we're going to check if the player's on the ground and if they're pressing the sprint button, then add to the movement how much they're sprinting with the X input, so how much of that direction times the base speed, so they sprint even more, and then also set the animation state to run, so they start playing the run animation. If they're not doing that, then set the animation state to be the walk animation state. So if you're not, and the last thing we gotta check for the horizontal movement is if the player's on the ground, but they're not moving at all. So you wanna set the movement to be 0, and then also set the animation state to be idle, so you know that you're not moving. So this was all for the horizontal movement. Now we're gonna get into the vertical, so jumping and falling. To start with jumping, you can check if you press the jump key and then set the move direction Y, which is the up and down, to the jump speed. And then also set the animation state to jump. Now, if you're not jumping, there will be gravity against you, so you have to set the move direction in the Y to minus equals the gravity times delta time, to add that falling effect. And if the move direction is less than 0 and the current state is jump, then you want to set the animation to be to fall. If you're moving below 0, that means you're falling downwards, and if you were jumping, then set it to falling. And now how set animation works is we pass in the state. If the current state is not equal to the new state that we just passed through, you want to change those states and then set the trigger on the animator to the new state .toString. The toString will convert the enum into a string, which is how the animator reads it in. So this is all for the player controller so far that we need. So I'm going to hand it back to Adam to implement it.
All right, thanks, Agusha. So now we're back in the main scene, and you can see we got our player controller script here, and we're going to put this on the player, but it's giving us an error here. So if we take a look at this, you can see it's mad because the player controller does not match the script class, and that's because when I named it earlier, I put a space here in the name, and you can see in here there's no space in character controller, or player controller. So we're going to remove that space and then drag it on there, and you can see it automatically adds the character controller and the player controller script. So now, okay, we can hit play, and first off, there's a few things that have gone wrong here. First off, he's flying, just floating around in the sky. His movement is really janky, and that's because there is something going wrong with the script. You can see the little red error message down below that is telling us that. So what we're going to want to do is go back to the player, and on this character controller you can see there's this green capsule, and that is his collider. So that is how he's going to interact with the environment. So I'm going to drag it up a little bit, and now he's going to be on top of the platform rather than falling through it. And this other error here is telling us that the input button sprint has not been set up. So you might remember back in the script when you were setting up sprinting on the character, there is an input that we need to set up. So we're going to go up here, and we're going to go to Edit, and we're going to go down to Project Settings. Open it up and go to Input, just under Graphics, and then open up this axis here. So these are all of the inputs that we can feed into Unity. So we're going to add a new one. So just change 18 up to 19. And we're going to take this, we're going to rename it to Sprint. Make sure you capitalize on the sprint, just like it is in the code. And we're going to go down to this positive button here. So here we're going to add in left shift. That's the button we're going to press for sprinting. There we go. And then we're also going to give it an alt positive button. So this one will act just the same as left shift, and we're going to do mouse 2 here. All right. Now that we have this input set up, the character should be able to move around. So we're going to hit play. And there we go. We're walking, but we're not turning for some reason. And at this point, we're going to have to call Agusha back in here and see if she can figure out why exactly we're not turning.
Okay, so I'm back. Let's find out what happened. Oh, it looks like I forgot to set the rotation during the script. And let's quickly just copy and paste it in. And so we just set the rotation and pass in that X movement that we calculated from before. And now it should work. And let's just see it before we call in Adam again. And whoa, it works. Okay. So Adam will continue implementing everything else.
Okay, so as you can see, we have our little bot here moving around. You can go left and right, you can jump. All of the animations seem to be firing off properly, but the one thing that's not happening is the camera's not following him when he gets to the edge of the screen. So we're going to have to make a little script for that, which means we're going to have to call Agusha back in here. One more time.
So let's start by declaring variables. So the first variable we're going to declare is the transform of the player's transform. And the transform refers to, it has its position, rotation, scale, all of those different values. If you look in this scene, you can see it at the top corner. And then we're also going to set up the camera speed, which on default we want 3. and then as well as we'll have the camera transform. And then we would want a vector 3 of the offset, so the distance on the start where the camera is relative to the player. And then we're going to break it down even more and have the X position, Y position, and Z position offset, so that when we write it in code, it's a lot easier. So the first thing is on start references the very first time the game runs with the frame, different than awake, because this object is showing, is the difference. Take set up what the camera transform is with the current game object's transform. Calculate the offset, so the player transform position minus the camera offset. In start, we get the camera transform, so we just do .transform, which refers to the game object that the script's currently on's transform. Then we'll calculate the offset. As I mentioned, it is the player transform's position minus the camera transform position. And then we don't want it to move on the Z-axis, so the Z position will be just the camera's transform position on start, so that it never updates. And then in update, every frame will update its X position, which we'll use math.lerp. .lerp stands for linear interpolation, which is you have the start value and an end value, and then you have a time value or a fraction value between from 0 to 1, and you determine how far along you want between those values. So for example, if you had the values were 5 and 10, and then the final value was 0.5, then the result you'd get from that is 7.5. So this allows you to smooth things out. So we'll do it for the X position. So we pass in the current position of the camera, and then we take the player's current position plus the offset, and then we find timed at delta time times the camera speed, so we want it to move along the camera speed. We do the exact same thing for the Y position, but instead it is the camera's Y, the player's Y, minus the offset Y, and then the same camera speed. And now we'll give it back to Adam to test out and implement correctly.
Okay, so now we're back in the main scene, and after applying that script to the main camera, you're going to want to drag in your player into the player transform down at the bottom, and then you're good to go. The camera should follow the player around. As you move, it's going to bounce up and down, move left and right. So now we can go back to the player and we can look at the player controller script. And here we've got a bunch of values that we can modify. We can change the gravity, we can change the jump speed. All of these will alter how the character moves. So if you turn the jump speed way up, gravity way down, you're going to fly up into the air. So find a value that you feel comfortable with. I kind of kept gravity at 12, jump speed at 5. I played around with the base speed in the sprint mod, so you could either be slower or faster, depending on how you want your game to play. So one important thing to note, I'm changing all of these values while playing, so as soon as I end, they're going to reset back to their defaults. So whatever value I find that I like, you're going to want to remember it and then put it back in once you finish playing. So another thing that you might have noticed is the character kind of floats above the platform. and that's because his collider is hitting the platform collider, and they're staying a little bit apart. So this value in the character controller determines the height of the capsule, so you can tweak that, you can drag it up and down until you feel comfortable with a value where it looks like he's touching the platform. So I got out 1.5 right now. And with this, you can see it looks pretty good on those platforms, but in these ones, his feet kind of sinks into it. So I think something maybe more along the lines of 1.7, 1.65 might work better. And I might need to adjust the collider on these gray and blue platforms instead. So tweak what you feel comfortable with until you get something that looks good and plays well. So I'm just going to kind of shrink the top of this, and then you can see I've forgotten my own rule here, and I adjusted the height of it while I was playing. So I'm going to put it to 1.7. So here I'm going to go back to the animator, and I'm going to tweak some of the speeds on the animations. I think the walk is a little bit too slow, so I'm going to go into the animator, and I'm just going to turn that up 10% to 1.1. And I think that looks a little bit better when it's playing. The animation's a little smoother, and it doesn't look like he's sliding across as much. So you can play around with the speeds of some of the animations until you find a nice balance. But that brings this episode to an end. So next episode, we're going to be covering pickups. We're going to be covering player damage, player death. When he falls off the sides of platforms, he's going to die. And we're going to be going over checkpoints as well. So that is all. This has been Adam at Brain Academy, and I will see you next time.